The next question we want to ask ourselves is which problem is a bigger problem? Which means, in a sense, if I had to solve one at the expense of the other, it's not just a theoretical discussion. Yeah, this is worse, that's worse. Suppose I had a solution that would increase memory leaks, but would solve the dangling pointer, or an alternative solution that would solve the dangling pointer but increase memory leaks. Which means when I come and discuss which is worse, I want to take into account. Suppose that one is um, at the expense of the other. So the question is, which one is the worst of the two? So the first point I want to bring out, which is something that the audience here brought up, is that memory leaks is something that are slowly becoming less and less of a problem. In a sense, if I talk about a utopian world in which I have unlimited memory, and that's a utopian world, so there would be no, I couldn't care less about memory leaks. I can leak whatever I want. What's the difference? So in a sense, it's true that we're not talking about a utopian world, but in a utopian world, memory leak would not be a problem, right? So the further down the line we are going, the less and less of a problem that memory leak is. That's one point to notice. Which means if we have to solve one of the two problems, so if I'm told that one problem is persistent, which means it's always there, as computers become more ubiquitous and as I'm getting more memory and I have 16 gigabyte RAM and one of these days or maybe I'll have 128 gigabyte RAM and I'll go up to I don't even know what, right? So the memory leak problem is actually going away, while the dangling pointer problem is not going anywhere. So that's the first point to notice, which I think is it's a very important point. Because if I had to solve one at the expense of the other, I would say to myself, well, this problem will never go away. And this problem is slowly going away. So even if today I have a problem, and even if I intensify the problem because of my solution, but over time, the problem would dissipate. And therefore, that would be a reason why I would rather solve the dangling pointer and not solve the memory leak. That's one point to notice. Again, there's no right or wrong here, it's just opinions. The second point maybe to notice is that dangling pointers are actually more difficult to catch during runtime. Yes, I can go and run things like garbage collection, whatever it is, to make sure I don't encounter the problem. But let's say I actually have the problem, and there's no garbage collectors and there's no anything else, and I actually have a problem. Now, the dangling pointer problem is a silent killer, meaning to say that the pointer and the code around it have no way of knowing that it's a dangling pointer, which means that if you go and you try to dereference it because the pointer thinks that it's still a valid pointer, and then you run into a problem, notice that you are in the problem and there's no way to, let's say, gracefully degrade the code because you thought that you're accessing your variable, you're actually accessing somebody else's variable. And then further down the line, you're even aware that vulnerability actually might manifest itself into a problem. While if you go and you have a memory leak, so you say new, another runtime tells you I got no memory leak, so now you can decide what to do with that information. Now you might ask, they'll be getting segmentation fault. Well, not necessarily, because if it's all the segmentation fault is when you try to access data that does not belong to your program. You're trying to pass segment lines, which means if you're trying to access some other program's data, you might get a segmentation fault and the operating system might throw you out. But if you, let's say, have two variables that belong to you, A and B, like the sample I showed before, and as far as the operating system is concerned, that is your data. And since that is your data, therefore, you are allowed to access that data any way you want. It's your memory segment. operating system is not going to do anything, it's not going to tell you anything. It's your memory segment. And therefore, if you might change data that belongs to some other variable of your code, who knows? And it might manage something itself into a problem further down the line. While memory leakage is something that is known. When I say known, you can put it in a try and catch and try to run a new, and then the runtime will tell you, sorry, it's no more memory, and you can decide what you want to do. You can say, okay, I'm going to figure out how to free up memory. Okay, I will gracefully run graceful degradation. Okay, I will write to the user, I'm so very sorry, you can't create a new ninja today. Or whatever it is, my program will keep running. I don't think, I encounter the problem, I encounter it in a controlled fashion. And therefore, probably the worst of the two is probably the dangling pointer. We will see that a lot of the solutions we will talk about actually solve the dangling pointer at the expense of memory leak. And that just shows that engineers out there actually believe that to be true. They believe that dangling pointer is the worst of the problems. Now, we will see that there are languages that do the other way around, and we'll have to explain why. But when we start on the journey of talking about these two problems and their solutions, we have to understand why would somebody want to solve this and not solve that? Why would somebody want to solve this at the expense of that? And I think that the two first basic explanations are that one is a persistent problem, while the other is a diminishing problem. And the second reason is that one is a silent killer, while the other one is a very noisy killer, which means it's true that if you need memory and you can't get it, then your program will have to will have to go, okay, what can I do? But you could do graceful degradation, meaning to say that I can shut down connections. I can do other things. I can tell the user I'm experiencing problems. Please A B C D E F, and not get that blue screen of death. Well, if you do dangling pointers and you have segmentations fault, for example, whatever it is, you're going to get the blue screen of death. It's out of your control. So for those two reasons, one might claim or should claim that a dangling pointer is the worst of the two, and it should be solved before we go around solving the other problem.